Hello everyone. Next, we want to make a summary about the disk method, the washer method, and the shell method. Okay. So if you are using the disk method, of course you will need to draw a disk. If you're using the washer method, then draw another disk inside the disk, okay, to form a washer. Let's say this is your axis of revolution, and you can see that the center, okay, the center of the disk. So this is your center. The center of the disk is always on the axis of revolution. Okay, and then you can see that the radius, okay, this is the radius. The radius of a disk will be perpendicular to the axis of revolution. Okay, axis of revolution, the radius, and this is important. For example, if you rotate around the y-axis, then your radius will be the x value. If you are rotating around the x-axis, then your radius will be your y value. Okay. Now, if you're using the shell method, then you will need to draw a shell. And you can see that the height right here will be parallel to the axis of revolution. Okay, parallel to the axis of revolution. For example, if you rotate around the y-axis, then your h will be your y value. Okay, if you rotate around the x-axis, then your height will become your x value. Okay, x value. Now, sometimes we need to take care of the problem that you want to find the distance between two curves, okay? Or if you rotate around like y equals 2 or x equals 1, the axis of revolution is no longer the x-axis or the y-axis, okay? So here, let's make a summary about the distance between 2 points. So let's say you have 2 points, they have the same x values, okay? X, they are the same. So that means they lie on the same vertical line. So this is the point, this is the point. They lie on the same vertical line. Let's make this point larger. Okay, and notice that y2 is greater than y1. So that means this point x comma y2 will be above the point x comma y1. So to find the distance in between, we have y2 minus y1, which is top minus bottom. Similarly, when you have 2 points, they have the same y values. That means they are on the same horizontal line. And x2 is greater than x1, so that means x2 comma y is on the right hand side, and x1 comma y is on the left hand side. Okay, to find the distance in between, we use x2 minus x1, which is right minus left. Okay, right minus left. So here we have a table, so let's take a look at this together. We want to rotate about the line y equals b, and notice that y equals b represents all horizontal lines. Okay, including the x-axis, because x-axis is y equals 0. Okay, and x equals a represent all the vertical lines, including the y-axis, because the y-axis has the equation x equals 0. Okay, so basically here you have the column of axis of revolution. Okay, axis of revolution. So let's draw a picture below. So let's say we have this region, strange region. Okay, if I want to rotate this region about the line y equals b, so y equals b is a horizontal line. So let's say here. and we want to use the disc or the washer method, then we need to slice the region vertically. Okay, so we need to slice the region vertically. So that will give us a washer right here. Okay, a washer right here. So you can see that if we slice the region vertically, then we will stack these slices horizontally. That means we need to integrate with respect to x. With respect to x. Okay. Now, if we're using the shell method, okay, shell method. So if you cannot visualize this, you can just think of this as the opposite method. Okay, opposite method. So for disc and washer method, you want to slice the region vertically, but if you want to use the shell method, you need to slice the region horizontally. So you can form a shell. Okay, you can form a shell. And you can see that if we slice the region horizontally, then we will need to stack these slices vertically. So that means we need to integrate with respect to y. With respect to y. Okay, similarly right here, let's say we still have this region. If you want to rotate the region around a vertical line using the disc or the washer method, then you'll need to slice the region horizontally because that will give you a washer in this case. Okay, so horizontally. Okay, and you can see that right here we stack these slices in a y direction, so that means we need to integrate with respect to y. Okay, with respect to y. Okay, now if we are using the shell method, okay, we need to slice the region vertically because that will give us a shell. Okay, and since you slice this region vertically, and you can see that we stack these slices in the x direction, that means we want to integrate with respect to x. Okay, so we don't have any examples in this note, but there are more examples, more practice examples on Canvas. Okay, again, please do not hesitate to reach out if you have any questions, and also please make sure you practice those problems, because the more problems you practice, the more familiar you will be with the materials. Okay, thank you.